Hello everyone. This question is from 9701 March 2020, and this is related to enthalpy changes. Right now, I have many of you asking questions from enthalpy changes, and most of you have problems with the cycles and questions from P1. So that's why now I'm doing some questions from P1, and hopefully you all will get the idea that how to solve these type of questions, right? So let's just look at this question. Now in this question, they're saying that they have given us two equations, right? There are two equations mentioned here. Let's just name these equations. This is equation number 1, this is equation number 2, and they're saying that sodium, in first equation, sodium hydrogen carbonate decomposes to give sodium hydrogen carbonate reacts with HCl to give NaCl, water, carbon dioxide, and we have delta H for this reaction. Then we have sodium carbonate reacting with HCl, gives sodium chloride, water, carbon dioxide, and the delta H for this reaction is also given, right? So these two equations are mentioned in the question. Now what they're asking for is that on heating, sodium hydrogen carbonate decomposes as shown. So this is sodium hydrogen carbonate. It decomposes to give sodium carbonate, water, and carbon dioxide. Now the question is, what is the enthalpy change for this decomposition, right? We have to calculate the delta H for this reaction. What is the delta H for this reaction? They have given us two equations. By using these two equations, we have to calculate the delta H for this one. Now, in this type of questions in which we have equations already mentioned, and by using those equations, we have to solve the delta H for the desired equation. Let's say this is our desired equation. This is the equation of which delta H we have to find. So the most simple technique would be to solve these two equations and convert these two equations into this one by adding these two equations, right? So how would we do it? Let's just look at this one. As you can see that we have sodium hydrogen in our desired equation. We have sodium hydrogen carbonate on the reactant side. So we need it on the reactant side. And in our given equations, again, we have NaHCO3 on the reactant side. That means this is fine, but we have 2 moles of NaHCO3 in our desired equation. And in our given equation, we have only 1 mole. So we need 2 moles of sodium hydrogen carbonate. So that means multiply this given equation by 2. And if we multiply this equation by 2, what would we get? We get 2 moles of sodium hydrogen carbonate. I'm writing the equation here. 2 moles of NaHCO3 plus 2 moles of HCl. Everything will be multiplied by 2, plus makes 2 moles of NaCl plus 2 moles of water plus 2 moles of carbon dioxide. And delta H would also be multiplied by 2. So 38.97 multiplied by 2. So we have 38.97 multiplied by 2, and that is equals to 77.94. So that means delta H is now minus 77.94, because initially it was minus 38.97. So we have changed this equation number 1 according to our desired equation. Now the next thing, we need sodium carbonate on the product side. But in our given equation, sodium carbonate is on the reactant side. We need 1 mole. We have 1 mole, but this is on the reactant side. We need this one on this product side. So how can we shift sodium carbonate on the reactant side? We just simply flip this equation. What we have to do is flip this equation, convert the reactants into products and products into reactants. So by flipping this equation, let's just flip this equation. So this would become, the reactants will become product and products will become reactants. So now we have NaCl, water, and carbon dioxide on the reactant side. So this is now 2 NaCl plus CO2 plus H2O. And now Na2CO3 and HCl is on the product side. So Na2CO3 plus 2 moles of HCl. And as you have flipped the equation, the delta H would also, the sign of the delta H would be changed. This becomes plus 96.59. Right? Now what you have to do is just simply add these two equations and you will get your answer. You can see that we have 2 moles of NaCl, 2 moles of NaCl on both reactant and product side. They get cancelled out. 1 mole of carbon dioxide, 1 mole of carbon dioxide, we only left with 1 mole of carbon dioxide. Water would be cancelled with water, we only left with 1 mole of water. And 2 moles of HCl would be cancelled with 2 moles of HCl. So finally we have our desired equation. We have 2 moles of NaHCO3. This is the only thing left on the reactant side, and now we have Na2CO3 plus H2O plus carbon dioxide. Right, this is the desired equation. You can look by yourself that this is the same desired equation whose delta H we have to find out. Now how would we find the delta H? Just add these two numbers. 77.94, 96.59 minus plus, it would be minus, so minus 77.94 minus 77.94 0.94 plus 96.59. So this would be equal to 18.65. So the final answer would be 18.65, and this is option C. Right? So I hope you understand that how to solve these sort of questions, right? I have solved this question in detail. Now let's just make one thing clear here. Let me just clear this whole thing. Look, you don't have to solve these equations on the paper. You can just simply do it in your mind, right? As you just see that sodium hydrogen carbonate, we need 2 moles on the reactant side. We have only 1 mole on the reactant side. Multiply this one by 2. So that means multiply the delta H by 2. We need sodium carbonate on the product side. We have sodium carbonate on the reactant side. Flip this one. Flip this one means sign of the delta H would become positive, and just simply add these numbers. That's it. This is all you have to do, right? You don't have to solve the equations. You don't have to get the desired equation just to prove this one that yes, we have the desired equation. No, just simply solve the equations in your mind and you'll get your answer. All right, so the correct option is option C.